Question 7. Triangles A and B are shown below. A and B. The triangles are placed together to form a larger triangle as shown. Is this larger triangle right-angled? Justify your answer. Right, so we have got a triangle and we know the lengths of the three sides. As soon as you see prove it's right angle or is it right angle, you need to start thinking converse of Pythagoras. If you know the lengths of the three sides, you're looking at converse of Pythagoras to see whether or not this is right angled. So stop the video, go and have a shot. Okay, first of all, the lengths of our sides. So this one is this one here, so it's 8. This one is this one here, so it's 19. And this is that plus that, so a total length of 22. Now, converse of Pythagoras is Pythagoras' theorem says that the longest side squared is equal to the sum of the two shorter sides squared, which looks like this. So c squared, the longest side, equal to a squared plus b squared. So longest side, 22, short sides, 8 and 19. So let's see what they equal. Okay, 8 squared plus 19 squared, that's our two shorter sides squared and added, gets me 425. Now I need to work out what 22 squared is. And the answer to that is 484. So these two numbers do not match. Therefore, by the converse of Pythagoras, this is not a right-angled triangle. And that's what we need to actually write down. Okay, so we say 8 squared plus 19 squared is not equal to 22 squared. Therefore, by the converse of Pythagoras, this is not a right-angled triangle. Done and dusted. Okay, marking scheme. So we are going to get a mark for our 8 squared plus 19 squared and the 22 squared. We get a mark for finding what they are and a mark for our conclusion. Okay, question 8. In the diagram below, RQ and PQ represent the vectors C and D respectively. Part A, express PR in terms of C and D. Go away, stop the video and have a go yourself. Okay, so we are looking to get from there to there, but we're not allowed to go straight there. We have to use these vectors here. So first of all, we are starting at P and we need to go to R. So we're going to go along here, so that's D. And then we have to go down there, which is the opposite direction of the arrow in C, which means we are taking that away. So writing it in terms of C to D, P to R is equal to D minus C. Okay, second part, the line QP, Q to P, this one here, is extended to T. They've stretched it out, they've made it longer. TP is equal to PQ. TP is equal to PQ. So that is the exact same as that. So P is halfway between them. V is the midpoint of PR. So V is halfway between P and R. Express T to V, so from there to there, in terms of C and D. Give your answer in its simplest form. Stop the video, go and have a go. Okay, let's have a look at this. So no T to P is the exact same as P to Q. So that means that T to P is also D. So we are going from T to V. So we're going to go along here, and then we need to come down there. Now we've already expressed P to R. We have said that P to R is equal to D minus C. So let's put that in. So just a wee reminder, we already know that P to R is D minus C. So what we're going to do is we're going to come along T to P, and then we're going to come halfway down P to R. Okay, so what we've got is we are going along T to P, and then we're going halfway along P to R. So we're going to replace these with D's and C's. Okay, so TP is equal to D, and a half P to R is equal to a half D minus C. We're told we want to do it in our simplest form, so we're going to multiply that out and gather our like terms. So multiplying that out, we've got our D plus a half D minus a half C. So we need to take this together, so D plus a half D. Okay, so a D plus half a D is 1.5 D, or 3 over 2D, and the minus half C just stays the same. That's in its simplest form. Marking scheme. You are going to get a mark for a valid pathway, and then your second mark is for simplifying it. Right, number 9, factorise 4x squared minus 25. Factorise. As soon as you see those words, you should start going down your list. Number 1, do we have a common factor? Number 2, do we have a difference of two squares? Number 3, all else fails, product and sum. Have a look at it, decide which one you're going to go for. Okay, let's go through our list. Do we have a common factor? Look at our numbers. We've got 4 and 25. There's nothing divides both of them. We have an x there. We've got no x's here, so there's no common factor. Next one we're checking for, do we have a difference of two squares? We have a takeaway. Good start. 4, it's a square number. X squared, it's a square number. And oh look, 25 is also a square number. So we've got a difference of two squares. So difference of two squares, you take the square of each thing, so the square root of, you take the square root of each thing, the square root of 4 is 2, so you get a 2 in each bracket. Square root of x squared, you've got an x in each bracket, and the square root of 25 is 5. One bracket has a plus, one bracket has a minus, done and dusted. Part B, hence simplify, in other words, you're using what you've got up here to simplify that. Simplify means you're looking to cancel something on the top and the bottom. So we need to match this up. We've already simplified this, it's that. We need to simplify this. We need to get this back into brackets. So again, go through your list. Do we have a common factor? Nope. Do we have a difference of two squares? Nope. Product and sum. Let's see if we can work it out that way. Okay, so to factorise this, we've got the 2 in front, which just makes it a tad more interesting. So we're going to take the 2 and we're going to multiply the negative 10. That gets me negative 20. So I am looking for factors of negative 20 that are going to add together to make negative 1. So first of all, just think of all the things that multiply together to make 20. So we've got 1 and 20, 2 and 10, 4 and 5. Now it's a negative, so one of them has to be a negative. And we're looking at having a difference, or when they add together, we're going to get a negative. So that means my largest factor has to be a negative. So if I shove a negative onto the biggest numbers out of the pairs. Right, now looking at it. What one works for us? 1 plus negative 20, negative 19, not what I want. 2 plus negative 10, negative 8, not what I want. 4 plus negative 5, bingo, negative 1. In other words, negative x. Just remember, we don't bother putting a 1 in front of there. Those are the two that I want. So I'm going to rewrite this now. Okay, so I've rewritten it using these factors here. So I've got 2x squared, that's no changing. I've got plus 4x minus 5x, which put together give me negative x, and I've still got my negative 10 there. Now I'm going to divide this up, and I'm going to pull out a common factor. Now remember, if it doesn't work, switch these round about. So I've got 2x squared plus 4x, I can pull out a common factor of 2x. Okay, pulling out a common factor of 2x, that leaves me x plus 2 in this bracket. Looking at this, remember I want to match this. So, common factor that I can pull out there. I need a plus in my bracket, I've got a minus there, I'm going to pull out negative 5 as a common factor. Okay, so I've got negative 5, x plus 2. Now my brackets match, so I've done it right. So I take my common factors and I put them in one bracket. So my 2x minus 5, that's in one bracket. And my x, so x plus 2, that's what we got in here. That's me, put it back into double brackets. So we've simplified the top, we've simplified the bottom. Now we want to look and see what we've got the same that we can cancel out. Okay, so we have rewritten this. This is what we started with, 4x squared minus 25 over 2x squared minus x minus 10. We've put top and bottom both back into brackets. Now look to see what you've got the same top and bottom that you can cancel out. Oh look, I've got a 2x minus 5 in the bottom and a 2x minus 5 on the top. I can cancel them out. Okay, so that cancels that, which leaves you with 2x plus 5 on the top and x plus 2 on the bottom. Okay, so our final answer is that. 2x plus 5 over x plus 2. Right, marking scheme. So you get a mark for, whoopsie-daisy, you get a mark for getting your difference of two squares, and I'm still wheeking this thing about. You get a mark for your difference of two squares. For part B, you get a mark for starting to factorise. So if you look as though you know what you're doing, so you've got 2x in one bracket, x in the other, 5, and then your final mark is for, not your final mark, your second mark was getting the actual complete factorisation, and your third mark is for cancelling and getting down to this. 3 marks for part B.